differences and implementation challenges, as well as some opportunities in this arena of analysis-ready data. And it's been organized, this session has been organized by the NASA ESDA Standards Office. We all, the organizers, work for NASA in some respect. I should have said that at the beginning. We work for different data centers or different parts of NASA. But this is at ESO, the NASA ESDA Standards Office that we collaborate in, is the NASA-sponsored group that formulates NASA's data standards policies across the board, and has recently started to take a look at analysis-ready data and even hosted a small NASA internal workshop on this subject. So the eventual goal of this session, is to build momentum and understanding towards harmonizing some of these diverse activities with regards to ARD and their definitions. So there's a number of sessions that have kind of related themes with regards to artificial intelligence on Thursday and Friday. There is some cross overlap, and hopefully you can attend those sessions as well. Good, so logistics, I've done the introduction. Hopefully you've already answered the first poll question. Just a brief reminder, there'll be 3 presentations. I'm not sure if Ignacio has showed up yet. He works for the ARD zone, industry ARD affinity organization. And then Steve Laban is from the USGS, but he's gonna be representing CIOS in this case and talking about the CIOS, that's the International Satellite Coordinating Activity, and their approach to ARD. And then Chris Linitz is gonna talk about it specifically a NASA focus. So once we get done with those talks, there'll be about 15 minutes each with about 2 minutes of questions and answers, again, through Slido. If you go back to Slido to the questions, I'm sure there's going to be questions in the chat, but if they're in Slido, put them in Slido so that people can vote them up. And then I'll moderate at least 2 of those questions at the end of each talk. And after that, that'll take an hour, a little bit less than an hour. We're going to move into some session breakout groups for about 20 minutes or so to talk about various themes there that I've listed there. They're also in the notes page to refresh yourself. So we'll have about 4, 5, 6 different breakout rooms moderated by the co-hosts. And then we'll come back from those breakout groups after they have addressed these themes and summarize them and report out. So that, in a nutshell, is what we're going to do. Hopefully, you've got the first poll question. And Shannon, are we on to the second poll question already?
Just activated it. Yeah, should be there.
Okay, there you go. So you can just type that, or think about that as we start these first set of talks. And you don't need to answer it right away, but perhaps in the next 5 minutes you can answer those. So we're going to move on to the talks now. And let me just do a quick speaker check. Did Ignacio sign on? Are you there, Ignacio?
I don't see Ignacio
okay.
in the list.
Right, so we're gonna move on to our first talk then, or the next talk in the row, and that would be from Steve. So Steve, go ahead and prepare yourself, and I'll stop sharing and you can grab control.
Okay, thanks, Ed.
Mute yourself again, thank you.
No problem, let's see if we can get her going here. Can you see my screen?
Yes.
Yes, we're good? Okay. I'm going to leave it in this mode. Otherwise, I'm going to lose my screens. So I'm going to just leave it this way. Hopefully, you can see my slides okay. So what I want to talk to you about today a little bit is the work going on within CIOS, which is the Committee on Earth Observation Satellites, in terms of analysis-ready data. And within that group, I'm a co-lead with a couple other folks, Zolti Zentai from the European Commission and Adam Lewis from Geoscience Australia. And together we're leading this land surface imaging virtual constellation work inside of CIOS. So what I'd like to do is just quickly give you an overview of CIOS and what LSIVC is. A little bit on definitions. I know this is always a big topic. And then the work we've been doing in terms of CIOS ARD for land, which we call CARD4L. A little bit more on specifications and compliance review process that we have in place, and then just a few next steps. So real quickly on CIOS, many of you may already be familiar, but this was a group formed back in 1984. It's really an international coordination group of civil space-based Earth observation programs that is really focused on promoting exchange of data and this interoperability question. And today it's comprised of over 60 members from over 34 countries. And within that are 5 working groups and 7 virtual constellations, which the land surface imaging virtual constellation is one of those. And so within the LSIVC, we've developed a definition for what we mean by CEOS analysis ready data for land. And I'll just read that out here, that we believe these are satellite data that have been processed to a minimum set of requirements and then organized into a form that allows for immediate analysis with a minimum amount of additional user effort, and keeping in mind interoperability both through time and with other data sets. We know definitions is an important piece, so we've tried to put ourselves in terms of in some context, and so we know that analysis ready data is a very broad term, and people use it in all sorts of ways, in all sorts of applications. Maybe can somebody mute? Perhaps.
Please mute yourself, whoever's talking besides Steve. I don't know if I have privileges to mute. Go ahead, Steve.
Oops, now Steve is muted. Hold on, Steve.
Do we lose Steve?
I think so. We might have done a mute all. Let me make sure Steve is unmuted.
Okay, let me try that now.
There you go.
Okay.
We got you.
Yeah, there must have been a mute all on that one. Okay. Okay. So within LSIVC and CEOS ARD, we've been trying to be very specific, or more specific than just that general term of analysis ready data. So CARD4L in particular is a very specific flavor where we have a definition for it and specifications that go along with that. And in terms of where it sits in context with all these other terms, we believe it's the starting point for some basic level of interoperability that is promoted through advisories and guidance to move along this continuum of increased levels of interoperability until at some point, perhaps a user may want to reach a fully harmonized data set. And then we use the term fused to mean almost like a new data set that's you cannot distinguish the inputs that are going inside of that new fused, I say, data set. This whole terminology question has been adopted within CEOS, and there's a terminology report that was just adopted and endorsed at our last meeting, and I put the link there for future reference. So for CEOS, we've really tried to identify the benefits of why we are doing this. Why are we defining these specifications in terms of 3 broad user groups: data producers, data distributors, and data users. And these are this information is out on our website, which is a link there on the page. And some of the highlights here are really to, as I've mentioned before, to enable interoperability, to provide consistent and high quality predictable data sets, and to minimize this cost component for additional pre-processing efforts that many folks do today. I've got a slide here on what CARD4L is and what it isn't. I guess what I'm just going to highlight a few things, just noting kind of the time we have available. But today it is about a geophysical parameter, which we define as a level 2 product within CEOS. So we're talking about surface reflectance, surface temperature, and in the radar domain, it's normalized radar backscatter or polarimetric radar. Its original development thoughts were to meet the needs of moderate resolution observations, this 10 to 100 meter range, but it's not intended to limit that. So it's really intended to address both higher and lower resolutions from there. And again, it's really set up to establish this minimum level of interoperability for time series analysis and data cube type of implementations. Just maybe to highlight what it isn't, it's really not limited, intended at all to limit or preclude space agencies from generating any other products they wish to choose. It's just one product, a common product. It's not intended to meet all user needs. We know that. It's not intended right now to include even lower level, like level 0, level 1 data, or even higher level 3 or 4 products. It doesn't dictate product packaging such as tiling, a format like GeoTIFF or COGS or HDF, NetCDF. It's not intended to identify a single metadata standard either, like some of the ISO or STAC standards. So really, it's not a standard, it's a best practice, and we are working though with standards bodies, with OGC in particular, but others like IEEE and ISO. So I'm gonna give you a quick overview of just the framework itself that we've developed, and at the top we have this definition, which I already read out, but within that and underneath that definition are a group of what we call product family specifications. So we've got several optical specifications, one for surface reflectance, another for surface temperature, and then a couple radar ones, normalized radar backscatter and polarimetric radar. We're also looking at additional radar specifications, a LiDAR specification, pretty busy right now on an aquatic reflectance optical specification, as well as a nighttime light radiance PFS. If a data provider wishes to be CARD 4L compliant, they do a self-assessment against these requirements. They submit it to LSIBC. LSIBC then works with an independent body, the Working Group on Calibration and Validation within CIOS, to do a peer review of that assessment. And also along that path, continually working with the data provider on addressing any questions that they may have. And at the end of this process, ideally, a data provider would end up with a CARD 4L compliant stamp. And just a little bit more about the specifications themselves that might be helpful. The specifications really have two levels. One's a threshold level and another is a target level. And to become CARD 4L compliant, it's the threshold level that's the minimum required. However, we do have target level requirements for those seeking higher levels of interoperability, as we talked about earlier. Over time, we do expect that some of those target levels of requirements may move into the threshold level. So that's an evolution of those specifications. Within the specifications, there are four categories, one on general or scene level or granular level metadata. Then there's a per pixel metadata section. And then we get into radiometric and atmospheric corrections and geometric corrections. Here's a quick snapshot of what that looks like. I just picked out one section. This is the general metadata, and you can see some of the requirements here are on the rows. And in these columns are both the threshold and the target level requirements. And data providers actually do their self-assessment right against this same specification in these columns, threshold self-assessment, a target level self-assessment, and then the explanation justification for those two levels that the data provider is trying to achieve. And then we also want to continue to mature these specifications. So we've got a column here for feedback if there's something that could be enhanced or improved with the requirement itself. And we do an annual review of these specifications to improve them. At the end of these specifications, just a summary table. I just thought I'd show you this. This is a quick scorecard, really, to show where each threshold and each target level requirement have been met or not met. So far, I'm happy to say the USGS's Landsat Collection 2 product has gone through this process and has been deemed CARD 4L compliant. We've got this up on our website today. However, there are several others in the pipeline. We've got a web page here that I've provided the link to. And so you can see the two Landsat Collection 2 products, the surface reflectance and surface temperature. We're also doing an assessment against the latest version of the specifications. And then ESA's got their Sentinel-2 Level 2A product in the pipeline. Element 84 has a Level 2A product. And then DLR has submitted an NMAP product. And I have personally been working with other space agencies as well on some additional products that hopefully will be coming on this page soon. Important piece I want to just show here is we do both the threshold and target levels of compliance on this page, but we also provide information about the self-assessment itself, the peer review response, and any sample data. So if you want to kind of get started, this is a really good page to use as a reference. Okay, quickly, where are we going? Really, we're looking for specification improvements. So we're looking for broader community engagement. We're also engaged with OGC on standards approaches. We're trying to broaden this within CEOS beyond just land. So we're working with the ocean atmosphere community. That's how I'm working with Ed a bit in that area. And then we're trying to provide and develop some guidance materials for those wishing to improve their level of interoperability, including going after things like standard metadata specifications, maybe some standard formatting or packaging specifications with other groups within CEOS as well. We're working with all sorts of data providers on trying to assure production and access, as I mentioned earlier, and also with enabling cloud platforms and cloud effective formats such as COG and Stack. We've got several pilots that we're undertaking, including one in Africa called Digital Earth. Africa, we've got an internal coastal project called Coast, and we've also just recently initiated a disasters pilot through OGC. And then, of course, we're trying to get out across the community as best we can, including things like ARD20, which Ignacio is heavily involved in, JC, VH Rota in Europe, as well as ESIP here today. So I'll just conclude then and just say if you want any further information, we have contact information here. Our secretariat person is Matt Steventon, and I've got his email there. He's a good point person, or of course me at any time. So with that, Ed, I think I'm done. If we've got any time for questions or how you want to navigate this.
Yeah, we do have time for a couple questions here for sure. And if you go, I'm going to go to the Slido tab, right? There's been a few questions put in there, and I'm just going to quickly look at them. There's a few of them. Maybe everybody could just go to there if they see a question they like to quickly vote on it. I'm going to pick one here, and here's a good question. This is from Anonymous, but it says ARD is a powerful holy grail and the card4L is so well defined. Is there a danger that people might think ARD is a solved problem? Can you respond to that, Steve?
Yeah, I would say we're just getting started. Yeah, maybe there is a little bit of a danger to that. I mean, ARD has been a very catchy term, but I think it's just been fairly recently when people really have gotten to a spot where they kind of are trying to understand it or getting to a level of understanding. And you mentioned, I think, Ed, too, that it's application specific. So there's a lot of variability yet. I'd say it's a maturing concept, but hopefully one that everybody's on board with. It's going to really increase the level of interoperability, not just within the land domain, but across multiple domains, including into the oceans and atmospheres. And I'd say especially when it comes to some of these transitional zones, like on the coast, where you need ocean and land to work together harmoniously. So I think that's a big piece, I would say.
Good. Okay, there's one more question that's been really upvoted here. The question is, does CEOS provide more granularity on what use with ease and confidence means for a new user?
Yeah, I think what we are trying to do from that perspective is to use this card4L framework and then expanding it into oceans and atmospheres so that we give users information about what specifications are being met with a certain product offering. And so the ease of use, by understanding and seeing the requirements, you can be guaranteed, I guess is what the thought is, you can be guaranteed that a product has met a certain level of quality standard quickly and easily. I showed those little scorecard summary tables, and that was kind of the intent of that we can give some sort of a level of assurance about what a certain product contains.
Okay, fantastic. See, I'm having little problems here navigating back to my screen here, but thank you for that presentations and all those wonderful questions and responses. Let me just do a quick speaker check. Ignacio, have you signed on yet? And are you there? I think we're going to move to Chris Lennis next. So Chris, just prepare yourself. Just quickly, is Ignacio, has he signed on?
I don't see Ignacio.
Okay, so maybe he's having some problems. Signing in, and I'm having some problems kind of getting back to the Zoom interface myself. I don't see where it is anymore. Too many screens. I see a little widget to the side here. Okay, so can somebody, Chris, can you just maybe just start sharing your screen here and see if you can take control?
It tells me I can't while the other participant is sharing. So maybe if Steve can release it.
Steve, can you release? Are you guys seeing my screen, by the way?
I think so. We're seeing a nice mountain foliage.
No, that's okay, but something happened to my Zoom interface, and I was trying to like share the Slido.
It says we're
I wonder if
viewing
it,
at
like,
Armstrong's screen though. So
Yeah.
maybe it's your other desktop.
Chris,
Yeah,
you
Chris,
should try sharing again. Chris, I made you a co-host, so you should be able to take it over.
No, I'm still getting that same error.
Okay.
And there's nothing I can do to release it. It already looks like it's released.
Let's see.
Okay, yeah, I'm not finding like the Zoom interface. Oh, there we go.
Ed, I just stopped you sharing. I was able to.
All right.
Okay, got it. So go ahead, Chris, share your screen, and let's proceed to the second presentation. And you have about 15 minutes to get through it, and 2 minutes of questions. Go ahead. Thank you.
All right. Are you seeing my screen now?
Yes.
Yes, we are.
All right. So you should be seeing analysis ready satellite data.
Yep, we got that.
Cool. All right. So thanks for that great intro, Steve. You've covered some of the stuff that I was going to need to cover as well. And so I'm going to just dip right down into a couple of the details that I want to cover with respect to NASA data. And that is, if we go back to that card for all definition, there's a couple of particularly cogent or salient words in there, I guess I'll say. One of which is the word analysis, and that is left unspecified on purpose because we don't want to specify analysis ready data only works for one kind of analysis. But it also raises some ambiguity in that there's so many different kinds of analysis. How do we know that we're making it ready for all those different kinds? And then the second aspect is this through time, analysis through time, which is kind of emphasizing the time series aspect of it. And in fact, time series has really been one of the killer apps for analysis ready data, and particularly in its data cube manifestation. And so I'm going to be drilling down into that a little bit with respect to some of the challenges that provides to some of our data. So the benefits, I think Steve talked about some of these. From a data provider standpoint, there's actually also some benefits. Like it makes us, it really crystallizes what metadata are important to include in there. It tells us that we really need to have easy to use spatial characteristics. And there's also a lot of cases or a lot of examples of particular corrections that need to be in there for confounding factors like atmospheric factors. And this is, obviously going back to primarily the land aspect. Once you look at atmospheric data, suddenly the confounding factors are sometimes what you're looking for. So, this will all mean that ARD will make time series analysis easier in general, particularly that easy to use spatial characteristics. And so it's been really picked up quite a bit by particularly applications. And I think we've also seen a lot of interdisciplinary researchers pick it up. So people that, aren't really down into the nitty gritty of how, level 1 and level 2 and instrument corrections work and even some of the geospatial aspects of the instrument. And so what we've been struggling with at NASA has these different processing levels. So we've got level 1, which is typically what we call calibrated radiance. Level 2, where we've converted that calibrated radiance into a geophysical parameter. And this one is actually showing methane total column from the air satellite. And then level 3, where we put it into some nicely gridded system. And this level 2 data is where we see some, like I said, particular challenges. And this is showing you the pixel layout of an air swath. And you can see that the pixels are their different sizes, even through this one scene. They're kind of diverging. This is near the pole where it becomes particularly difficult. And so the question is, well, how is this going to work out when we try to do time series analysis? And this is an attempt to demonstrate why this is hard. This is actually showing the air satellite passing over the San Francisco Bay Area for a week. And the different colored dots are where the centers of the pixels fall. And you can see they're falling all over the place. And so if you're going to be trying to do a time series through this, it becomes quite difficult to figure out, well, exactly which points should you include, and just how do you find those particular points within the swath, considering that you have to open up, each one of those individual data files and seek out, the closest point to what you're looking for. So level 2 time series looks like it's going to be hard. Now, we could aggregate to level 3. I mentioned that's gridded data, and it regularizes the geolocation, makes the geolocation so much easier to work with. But there's some downsides to that, and that's what I want to bring up. The first one, the most obvious one, is the cost of spatial resolution. Here I'm showing surface air temperature. This is again from the AIR satellite. And this is a level 3 gridded product. And you're going to see that same grid day after day after day. Those grid squares are going to be in exactly the same position. So it's virtually trivial to construct a time series for any one of those grid cells, or even an average over an area of those grid cells, or what have you, because all of those grid points will be in the same place with each successive day. But if you go over and look at the level 2 surface air temperature, we've seen that, yes, the pixels are falling all over the place, but on the bright side, we got much higher spatial resolution than we get over with the level 3 surface air temperature. And so, one of the big questions is going to be, well, how much spatial resolution are we willing to swap for that regularized geolocation? But there's something worse, I think, or more insidious, I guess, which pops out when we start looking at this in more detail. And in this case, what I've done is I've taken those previous 2 scenes and I've actually subtracted one from the other. And so what we're looking at is the difference between what the level 2 swath is telling us and what the level 3 grid is telling us. And if you just focus in on this particular one that I've circled here, which is the worst of the lot, you can see a lot of variation through this. And the variations are quite large. I mean, that's a temperature difference approaching 10 degrees Kelvin. And so that's kind of telling you that, the extrema in particular are being lost when we go from level 2 to level 3, or when we go from level 2 to level 3. And I think what we're learning now, particularly with climate change and things like that, is that the extrema of some of the measurements we're making is as important, if not more important, than the averages. And so this is, like I said, kind of one of the insidious aspects of going to level 3 from level 2 and not even really knowing, without doing this comparison, not really even knowing what information you've lost along the way. So here's some more caveats. We looked at the first couple: spatial resolution, suppression of extreme values. That bias that I showed you there, actually, let me point out that I circled that. That is the Death Valley National Park. And so that gives an explanation as to why, we have this area that's so hot relative to everything around it. And that is always going to be relatively hot, according, relative to the grid cell, because remember, those level 3 grid cells stay in the same place through time. So we get a systematic bias over time in that case. There's some other stuff. You get some day boundary artifacts, and I'm not even going to go through all the rest of them. But again, these are subtle things, but yet they may be very important when you're doing any kind of numerical analysis, and particularly statistical analysis. So we had a workshop back in November, and we looked at a number of different facets of level with respect to the analysis ready data and analysis and NASA data. One thing we decided to do, I think, is try for some quick wins with the level 3 and level 4 data. Level 4 is actually model data, so it's been gap filled. And it's not that level 3 data is useless, it's just that you have to be careful when you use it and what you use it for. And so I think by adding some key metadata and protect some key information, and especially some caveats, that we might be able to get some quick wins with the level 3, level 4 data with respect to ARD. The other thing we're doing, Steve already mentioned this, is engaging with CIOS with respect to ARD in the other disciplines. I believe this problem is more significant in the atmospheric and oceanic disciplines, perhaps, than it is with the land. And then thirdly, I think what we're going to try to do, at least within NASA and hopefully within the larger community, is see if we can apply a more nuanced approach to working with level 1 and level 2 data. Let me show you what I mean by that. That is that there might be more than one way to make the data analysis ready. So one way to make it easier to analyze is by making the tools more capable of analyzing the data. So in other words, instead of modifying the data to make it work with the tooling, we might instead modify the tooling to make it work better with the data. We might also look at some modifications to how we organize the data, having examples and tutorials out there on how to work with level 1 and level 2 data, what we typically call capacity building. The other thing we're looking at is supporting on-the-fly gridded analysis-ready data. And the nice thing about that is, at least you can defer that resampling as long as possible to limit the information loss, and maybe even give the end user some control over how much they degrade that spatial resolution in going from the level 2 into a gridded form. Now, this is just a quick example on what I mean with respect to making the tooling work better. In other words, making data easier to analyze. Here's a case where I took those AIRS observations and I binned them without losing the actual spatial, the exact spatial information, binned them into grids. And we often call this a level 2G, except in this case, I've also stacked them over time. And when I do that, I just did this with a kind of a simple little binary format, but could be done with a more standard format. When we do that, now the miracle of some of the stuff that you find in NumPy and Pandas allows us to do a very simple time series analysis. In this case, I'm actually picking the data closest to a given point, and it's taking me 6, pretty simple Python statements to accomplish that. So I think it's a case where, it's a sort of proof of existence that we can make the tooling work better to make the data easier to analyze. And with that, I think I'll stop.
Okay, thank you, Chris. Excellent, very nice summary presentation there. And we'll move on to the Slido poll now to see what questions have popped up there with regards to this. I see a few new ones here. See, nobody's really voted on anything. So maybe I'll just pick something here that's germane to your presentation. Okay, from Anonymous here is a good one. Does moving, these questions are like bouncing around as people are voting on them. Does moving from level 2 to level 3 always require lower resolution? Why not use a level 3 grid of interest along with an interpolation model of the L2? So I think you briefly touched on that, Chris, but maybe.
That's actually a great question. And I think it's perhaps easier to, maybe a little bit easier to do with the land data. With atmospheric data, I mean, sure, we could do a high resolution level 3 product, but then I worry that we're actually kind of fooling the user as to how much information content there is in that. And so all I can tell you, I guess, is that the scientists that produce these products, when they go to level 3 for atmospheric and oceanic, they almost always have a significant degradation of spatial resolution because of the risk of injecting science artifacts. On the other hand, with land data, there tends to be a little bit less degradation, but there's still some degradation in going from level 2 to level 3. I mean, essentially what you're doing is you're moving the location of that data value from where the sensor thought it was to where your grid center is. And that makes scientists very nervous.
Thanks for that. Another question, in terms of easy to use spatial characteristics, have you considered using a standardized hierarchical spatial indexing system like h3geo.org? So h3 is that's kind of new to me, but Chris, have you heard about that or thought about spatial indexing?
I don't know about H3, but I do know that the NASA Access program had funded a project by Mike Riley and company to do something similar to that, where they do a trixellation of the Earth down to a particular resolution. Actually, they do a multi-resolution, and then they basically map that into an index. And so that looks like another promising way to make the tooling work better. I have to say that, you really have to completely rely on the actual software that's working with those indices, because they tend to be pretty opaque to the average user. And so that's a case where, are you going to trust that, that software that's manipulating those grid indices? And I think that technology maybe has a year or two to go before it's really, ready for the common usage by, the wider community.
How does H3 compare to the stair indexing approach? Do we know? Can you comment
I'd
that on,
have to
Chris?
go Google H3 to say for sure.
Yeah. Okay. Well,
It's
maybe that's
also
something that
similar to the
they can come
DPDS
up with.
approach in OGC.
Yeah. The other person who posted that question, maybe you can raise that question again in the breakout session, so we can drill down a little bit deeper into H3 and how it can be a factor in ARDs. Let me see if there's another question here. We certainly have time. I'm going to check about Ignacio here in a second, but he's having some difficulty.
Can I say something about the H3? Alexander Yelena here.
Oh, go ahead.
But just briefly.
Go ahead, Alex.
Yeah, because of the CEO's speaker mentioned OGC. Well, there is a big effort to OGC called Digital Global Grid System, DGGS, of which I think H3 is one implementation. So if you're talking about aligning things with OGC and ARD, I think that's one interesting area to really think about.
Yeah. Okay. So yeah, I think the main difference is just the details of the implementation below that, but it sounds like they're both roughly the same kind of approach to working with geolocation, and particularly complex geolocation. That is very promising. I think we will get there eventually, but I don't know if the software level of support is quite there yet. To bring on all those applications and interdisciplinary users. I'm very hopeful about it though.
Okay, maybe one more question for you, Chris, just kind of briefly, kind of on logistics here. There's one question that says, how did you create the AIRS L2G time aggregated data before you ran or run pandas?
Yeah, so essentially all I did is I downloaded, I think it was like 500,000 AIRS files. I was doing it over continental US, and then I would basically run through all those AIRS files and drop the data points into those 1 by 1 degree bins, but still retain the exact lat and long. And that's what allowed me to do that, pandas trick, essentially to pull out the closest data point. It's not an approach that I would propose as an ongoing thing. I mean, I would prefer to use something more robust than that simple binary format that I was using. And so I'm kind of looking into what some of the point tiles approaches are looking at. I think that might be a way forward in the future, is essentially to treat all the level 2 data as point clouds rather than as swaths or curtains or anything like that. Because there's some good developing technologies that are working on how to work with the point cloud data in a geospatial sense. Okay,
that's good to know. Good. I see a little bit of chatter in the chat box. George has responded with some information on H3. It's a discrete global grid system, I guess, coming from URBA. So that's news to me, and perhaps we can do a little deeper dive in the breakout on that. I think maybe one more check here for Ignacio. We asked him to call in via phone. He's having some connection difficulties on the internet. But if does anybody, is Ignacio there? Or does anybody know anything about Ignacio? Shannon or Alan or Steve?
This is Annie. Megan said that she gave him connection information. But
yeah,
is anyone else going to say anything?
I haven't seen anything since, so.
Yeah, he seems to be
Sorry, I'm chatting with him. I'm sorry. I was looking for the mute button. I lost power here, tried to join on 4G, but even the 4G has died on me here. There have been intermittent outages since the last couple of days. I'm really sorry. I can't really join and present with no power and spotty internet. I have shared the slides with Ed, and I'm happy to discuss and present in other venues as possible or needed. I will join if I get power back, but it looks like it is bad.
Yes. Okay, so that's too bad that Ignacio couldn't be with us. I just was looking at his presentation and looked like a really super interesting presentation. You know, kind of coming from a little bit, well, you know, perhaps a little different angle with regards to looking at ARD readiness at the level 1 and level 2 data and level 3, level 4, as we heard in some of the other presentations. But I did ask him if we could share that. I didn't see a respond to that, but I'm sure maybe after the fact, we can link it to Figshare, and you guys can review it. You know, I'll just maybe just kind of briefly show the slide, the title slide here. So sorry about that, Ignacio.
I'm going to.
You've been a great contributor.
I'm going to send him the dial-in information. I mean, after all, he responded to this message. It might have been, you know, via his cell phone. So hold on one second.
Yeah, he did get the dial-in
oh, he did.
information.
Okay.
And I'm just looking at this last. And so, yeah, he's just happy to clean them up and have them posted. So we'll look for like Figshare after, you know, after this meeting closes this evening or something like that, or tomorrow. Okay. But yeah, sorry about that, Ignacio, and sorry for the audience that he couldn't make it. But we're going to kind of move along here. So we're about halfway through our session. I think we'll probably have a little time to stretch our legs a little bit with Ignacio not being here. We did have a little bit longer Q&A session. I think the next part of this session is we're going to go into breakout rooms to talk about some of these different themes that we ask the you know, the audience to address here. But before that, I think we're going to go to a review of the poll questions that have been super interesting, especially like the little word cloud for the last question that we had that, you know, required a little bit more thought and maybe a sentence or two about, you know, what ARD means to you. So I'm going to pass it over to Shannon, and we're going to quickly look at the poll results and maybe just kind of get a quick little feedback, and then we'll move on to the logistics of the breakout rooms. All right, so Shannon, you have control.
All right, can you guys see my screen?
Yes.
Okay, good. Yeah, so the poll results I think are just kind of interesting for us, even a nice segue into the breakout room discussions. So, you know, the first one everyone answered when it comes to ARD, I have a lot of people enthusiastic, so hopefully we have some lively discussion in the breakout rooms. And then in terms of the word cloud, so, you know, a word or phrase do you mean to you? You know, you can see that cloud optimized, standardized, and clean were very common themes, but we also have, you know, a lot of different ideas from all of you on what ARD means. So I think really what we want to do, oops, sorry about that. Let me go back to my Kiko chat tab here. Not sure what that is. There it is. So I think what we want to do now is just break out into the topics. Sorry, I'm looking for the questions here. So these are the questions we're going to focus on. So, you know, for those of you who are more on the side of ARD producers, you know, maybe you can speak to your organization's approach to producing ARD. For those of you who are maybe more consumers of ARD, you know, what use cases does ARD fulfill for you? And definitely feel free to speak to both of these if you sort of represent both sides of that coin. And I think we're also interested in hearing, you know, if you have ideas for how ESIP should get involved, and if so, how. So I think now we're ready to get into some breakout rooms.
So how many, just to recheck in on breakout rooms, how many folks would you guys like in each? So we've got about 73 people right now. So would you like to just do 4 rooms, or would you want smaller groups?
I think 4 rooms. Ed.
Okay, yeah, that's sort of 4 rooms, so that's like about maybe 15 plus a piece. I think that will be good. Yeah.
I was gonna say some folks are dropping off, but yeah, I could do 4 rooms, and I'm gonna assign automatically. So you're gonna get put into a room, and reminder that if you're a co-host, you can move between rooms. And when would you guys like me to pull everyone back? How many minutes should we do for this first one?
Let me see, remind me, Shannon, what do we have, like 20 minutes or 15 minutes for this?
Yeah, I mean, our
Breakout?
schedule's a little thrown off, but I think if we had, maybe 20 minutes or something.
I think 20
20
minutes tops, then we'll have at least like 10, 15 for wrap up.
Okay,
And,
great.
yeah, that
Okay, well,
sounds
I
good.
will
So why don't we
open.
go ahead and jump into the 4 breakouts?
Okay, here you go. Minutes.
Annie,
Oh, hey, Rich.
sorry. I'm assigned to breakout room 3, but should I go somewhere else?
Oh, no, that one works. Did you, I guess you were not put there automatically?
Looks like I was, I think.
Oh, you were, but you're not.
But I jumped back because I think it seemed like everyone was there, but maybe not.
Oh, no, there is, let me see. There is.
Okay, we'll just go back to
I would say, yeah, hop back into room 3. That works.
Okay.
So seems like a good spread around all of the rooms.
Okay.
Let's see. I can move Zach. Zach, we're all in breakouts. I'm going to assign you to a room. There you go.
Assign me to room 1, please.
Assign you to room 1. All right. You might be able to move over. Let me find where you are, Ed.
Yeah, I couldn't, I was able to leave the room while I was in, but I can't find a way to go to a room.
If you click on the breakouts button at the bottom, do you see that?
Breakout rooms.
Yeah,
I do see that, and there's a little menu that comes up, but how do I join a room?
Does it show an option? Does it say move to?
No, it doesn't show that.
Okay, I can do it. I'm going to move you to 1. Okay.
Yeah, we were cut off.
I was just wondering, does the Pangeo list qualify? Do they have an ARD metric? I don't know much about Pangeo, but I was introduced to it a couple of days ago by my colleague Douglas and some others.
Yeah, I mean, Pangeo is a computing ecosystem, and many of these ARDs are built to work in the Pangeo ecosystem. So many of those data are the ones that are in the open data registry. Many of them are like bundled with Pangeo and stuff. So, I guess, Pangeo is the ecosystem, and then you put the ARD data set within that ecosystem.
I will add that in our group we talked a little bit about expansion of ARD to include more than like remote sensing data and time stacks of remote sensing data, and as you say, Pangeo has definitely been not kind of pushing on those boundaries, like exploring not only ARD in the context of remote sensing, but in the context of climate modeling and other kinds of modeling. So there's a lot of good info there. Please join the Pangeo discussions or the Pangeo discourse. I feel like this is where a lot of the good talk about ARD in the context of, outside of remote sensing is happening in the modeling world.
Yeah. Now, Rich, with Pangeo, is the group kind of working towards like standardizing any kind of like ARD formats? Or, I mean, I'm certainly they're working in the arena of cloud optimized formats with like ZAR and things like that. But is there anything to do with like on the analysis ready data end, to hit on these things like the data set documentation, the metadata, and the uncertainty and all that stuff?
Not really, no. I think the focus really is on cloud, optimized data, and and their main concern is like how quickly can we load this data in, in the various tools that are popular in the Python ecosystem.
Got it. Got it. Okay.
Hey,
I think
I finally managed to join. I have a little bit of internet.
Good.
This is Ignacio. So I'm just here if there's any questions or if you want me to participate.
I'm sorry that we didn't have you early. Yeah.
I lost power and everything. That's fine. I'm here listening and supporting.
Yeah, so I'm sorry you weren't with us. We're in the breakout rooms. We've done the speakers and stuff, and sorry we missed your presentation. But it's good to have you here at these these final minutes here. And we'd like to post your presentation on the ESIP Figshare site eventually after this meeting. Good, you're breaking up a little bit, but thank you. So I think we have a few more minutes. I wanted to perhaps just quickly touch on this theme right here. How should ESIP get involved in analysis ready data, and how are there some perhaps collaborative activities or things that this session perhaps could kickstart? Does anybody have any ideas or thoughts on that?
Well, I will mention one thing that I mentioned in the breakout too, is that there has been some discussion of this kind of topic in the ESIP cloud computing cluster that meets monthly. Patrick Quinn is is leading that effort, and we've produced some documentation about things about like chunking strategies and performance of different types of data sets, but not like you said, we haven't really gotten into the more sort of user metadata aspects of it.
Mm-hmm. Now, where's Patrick? I mean, he works for NASA and stuff, but what project is this you're talking about?
Well, it's just part of the ESIP computing cluster.
Oh, right, ESIP computing cluster. Yeah.
Oh, sorry, cloud computing.
Yeah, cloud computing. Right. Okay, yeah, that's a natural.
I think he's part of the Earth Data Cloud team.
Mm-hmm.
I guess another question would be.
Yeah, Patrick's on ED2. He's a colleague of mine, both at NASA and L94.
Got it.
Ed, I was going to say, beyond the should you get involved with it, would be, are there any resources or, how could, is there any way that ESIP could better facilitate moving forward here? So I guess part of it is, should this be a topic discussed within ESIP? Well, it already is, but are there resources or are there ways that we could better support some of the problem areas that you've all discovered, or what is the problem space, and is there a room for ESIP to play a role in helping in that problem space?
Yeah, so I think defining the problem space and it's a good suggestion.
And one of them we were discussing in the breakout was training, and how do we get people spun up on all these issues, and where to look for resources and tools for how to do this stuff. And frankly, it's like, I mean, I'm buried in this stuff, but I still find it super confusing. There's all these different groups, and it has all these different materials, and Unidate has their stuff, and the University of Colorado has a whole nother set of stuff, and Pangeo has some stuff, and it's super confusing for a person just trying to get into this. So I don't know if ESIP could play some role there. I don't really know, but
well, one idea I would like to suggest is perhaps having something like OGC testbeds, where ESIP lab or someone could organize, where you could essentially evaluate different approaches or different ARD data organization restructurings or whatever you want to call it. I think where people could essentially have the same data and then start accessing it from different interfaces and trying to see how that all works around. Maybe that would be one possible area of
so Alec, the OGC model brings like the data and the recipes all together in one location or something, or how does that, what are you suggesting there?
Well, OGC testbeds, I think, are, I don't know if George Percival is still in the corner. He probably can explain it more, but you do have, you have sponsoring organizations. In this case, would probably be easy, but at least sponsoring organization could be those providing data and making efforts to provide data in some common way, commonly accessible way. And then you would also recruit people who would like to serve that or access the data through their own interfaces, either community or whatever. And then you would have some kind of a write-up and say, okay, this is what worked, this is what not worked. The final product of those test beds is in engineering reports, which basically talk about problems and issues discovered. And from those engineering reports, you then basically are able to define the future direction but in this case for OGC standards. But we could do something about it, because again, ARD is a lot of things to a lot of people, and so I think that something like that might be a role for EC.
Steve Laban, could we sneak this into the existing OGC disasters pilot?
Is Steve on?
I see him on, I think. He might have stepped away though.
Well, let me see what we're doing for time here, Andy. I think how much time do we have? It's this session is supposed to wrap up in 12 minutes. So
yep.
So Alex, the OGC approach is good, but it's very labor intensive.
Yeah.
And I don't know if a loose knit group like ESIP is really well suited in that case. The thing that occurred to me when you started talking though is your HDF zoo. And so HDF has this, what they call a zoo, where they've got samples of all different kinds of data products. And it's a really good repository for trying tools out on data. And I wonder if having something like that might be a kind of a lower cost way of accomplishing the same thing. In other words, to have a zoo of analysis ready data. And so you could come to that zoo, you could see good examples of analysis ready data. You could see other examples which are not quite analysis ready. You could come in, test the tools with the ARD to see how well is that tool working with ARD? And if it's not working well with it, what's the part that's missing that might need to be added to analysis ready data?
How big is that zoo, Chris? Like how many, how many different data sets are there? Is it a bucket and it's fairly unorganized, or is it a slick interface that you're able to search?
It's closer to a bucket than a slick interface. I don't know, Alex, do you know how many you guys have there? It must be thousands of data sets now.
I actually think that Joe Lee from my company is also here, so he can be more precise. But I would say it's pretty extensive. Joe, can you say?
Yeah, I think we have about 500 examples per language.
And so you could take examples, for instance, of the stuff that's passed the CART-FREL criteria and put sample files in there, or like I said, in a bucket, maybe with a simple directory structure. And then come along and try the various tools, try the Pangeo suite, for instance, try GDAL, try those kinds of things to see how well it works with those data.
This could also be just occurs to me based on that suggestion. This could be also just a new topic area on the Pangeo discourse, and we could point at the HDF zoo, or we could point at the new Landsat collection, or any other data through that kind of, and have a nice place to discuss it, as well as post example notebooks or whatever we're doing with it.
Okay, let me see. I guess I didn't realize that we're all back in the same room right now. So the breakout sessions have ended, and we have about 9 minutes to kind of wrap up. So I think the organizer, I think we were just going to give like a short kind of report out from each one of our breakouts. We've kind of already started that a little bit, I think, and then maybe some clothing thoughts of new directions and new ideas. So yeah, I'll start first, and you guys prepare yourself. I think my group certainly was heavily focused on the use cases. A lot of interested users, not too many producers, but we heard several interesting use cases bubbled up. Of course, the science interdisciplinary use case is tremendously important, and we also had a nice insight from Rob, who gave us the space perspective, where things like uncertainty documentation and having machine consumable uncertainty information right at the get-go is important for data usability and data assimilation. Another barrier that we kind of identified was in the GIS. There's also issues of on the fly and quality control and data understanding. They're important to take like a satellite record and bring it into a GIS. We talked a little bit about Pangeo and its role that it can play potentially in this arena. Of course, Pangeo is a nice cloud-friendly computing ecosystem. And then we talked a little bit about how ESIP can be involved. I think some of that has kind of really bubbled up now organically in the last few minutes. And I like Chris's idea of looking at the HDF zoo. So that perhaps could be one thing that we can look at it, and maybe ESIP can help with that a little bit. So that's a report from Breakout Room 1, heavily focused on the users and use cases. So go ahead, Breakout Room 2. Who is leading Breakout Room 2?
Right. Well, hi, this is Steve. We kind of got bounced around, so I ended up in Breakout 2. Actually, Chris had already started some discussions there, but I was taking a few notes in the document. I think some interesting discussions. We had quite a good discussion about some of the considerations around on-the-fly analysis ready data. As a way of providing access to, particularly things like sort of level 2 data. The advantage of on-the-fly processing is that you're deferring some of the decisions until the time of actual processing. So I think one of the examples that was mentioned about projections, that we don't know which projection a user may be wanting to use, but if we defer that decision until the time that the data is actually needed. But obviously the performance issues with that, but we see cloud and improving processing powers as some of the ways of addressing that. Chris, were there any other major topics there?
Well, I think there was an overriding theme that we came back to again and again, which is that there may be differences in what analysis ready means between, say, land and atmosphere and ocean, or between applications users and researchers, or between one agency like USGS and another agency like NASA, who has more. Obviously, NASA has more ocean and atmosphere stuff, so we have to worry a bit more about that. We also have more research users, and that kind of pushes us in a somewhat different direction than the USGS, which is more oriented towards land and I guess I'd say interdisciplinary and applications users. Even to the point where we have different definitions of level 1 and level 2.
We got to converge somewhere, right? Okay, thanks for that, Steve. How about Breakout Room 3?
I'm happy to speak. I took some notes, but Rich or others definitely step in. I would say a lot of our discussion was actually on some of the efforts that the cloud computing clusters focused on. So, Rich was sort of speaking to the idea there's potentially an argument that, kind of the first step in sort of the cloud world is, we need the rechunking step. So it's arguable that that's sort of like, the first step in analysis ready data. I think we mentioned the importance of metadata, CF conventions and whatnot, particularly optimized formats and the workflows for users in the cloud. I think there was a recognition that, the ARD topics that were discussed today, probably primarily by the speaker, the time series, and I think the group spoke to the need for expanding that, to other types of data, model data, and just non-satellite data, really. We talked about forecasters and their needs. So, I think that's, and folks like the idea of improving the tooling and helping people learn how to do different things. I think we recognize that ARD is in the eye of the beholder. And so any other thoughts from group 3?
I'll only add that I remembered what I guess on Pangeo that we've been saying ARCO, like analysis ready cloud optimized data. To kind of, that was one of the questions that came up, like, does it have to be cloud optimized to be analysis ready? And then we were like, oh, well, I guess not. You know, but so there's a, you know, another term we can throw around. I don't know if that's adopted by anybody else other than Pangeo. I don't know, is that a common term?
Yeah, probably will be pretty soon. Okay, thanks for that report, Shannon. It does seem that, you know, the more disciplines or the more different perspectives we bring into the RD, it's hard to like kind of like, you know, converge on you know, common definitions or common approaches. But you know, that's part of the challenge of like opening this arena to, you know, beyond where it's, you know, the people that have looked at it in the past. So just to be expected. All right, so the last, let's room 4, session breakout 4. Can you give us a quick report? And then
yeah,
I
think we had a good group with a lot of variety of people and perspectives. I'm going to jump way up to a higher level than the notes that were taken. By the way, somebody took really fantastic notes. It wasn't me, so whoever did that, thank you. I guess what I would pull out of it is, you know, the concept of on-the-fly ARD, I think, is important, and people seem to be excited about it, and there's that seems to be an area that people are doing some good work in. So ARD services and tools, not just data. Another topic that came up is ARD being used to feed into AI and machine learning pipelines. And I guess, you know, Doug Grau's sessions are going to touch on that. So you know, stick around for the rest of ESIP and learn more about that. Then I think people have trouble talking about ARD at the nuts and bolts level without using the word format. And so, you know, the format, I think, is a piece of this ARCO thing, which I think for a little while we were using a term analytics optimized data store. But you know, format is kind of the where the rubber meets the road. You know, that's what the code actually has to suck in or spit out. And so that's something that we shouldn't lose sight of. You know, that we can have all these great sort of conceptual definitions of ARD, but in the end, you really do need to have something that you can code around and actually build systems with.
Good, that's excellent. Thank you for that report, Alan. It sounds like you had a really engaging discussion there, and I agree with many of the things you said, including looking at the foundational formats that feed into ARD, or as you said, that's what the code operates on. So yeah, we're coming up to the half hour there at the end of our session. It was fantastic for your participation. I'm sorry Ignacio could not be with us. He did kind of make an appearance in my breakout at the end, but his talk will be posted on the Figshare site at some point in the very near future. And I think we've built up a lot of good energy and momentum here. You know, there's these sessions tomorrow and Friday on AI. That's very kind of a closely related topic, accessible or making data ready for AI. Kind of some of the similar themes led by Douglas and his team. There's a session tomorrow and then a panel discussion on Friday. So I would encourage you to attend those sessions. I think going forward, there's a lot of good ideas that bubbled up here about how we can continue to collaborate. Certainly perhaps the ESIP cloud computing cluster is one of the, would be one of the gateways to kind of like continue this discussion. But also let's think about for the ESIP summer meeting further down the road, if there's some kind of collaborative activities we can start building towards, perhaps some kind of interactive workshop where we like look at some of these techniques of on the fly or data conditioning in preparation for ARD and things of that nature. I think would be a good thing to start thinking about. So, well, it's 9:31 here on my clock. I think we're coming at the end here. And unless anybody has any last comments or observations, I think we'll go ahead and close the meeting. And thanks for everybody's participation. Yeah, there's a few little things going on in the chat right now. I see Ignacio popped in there with a little comment on defining ARDs. So thank you for that, Ignacio. And again, sorry we didn't have you. Hopefully this chat, I'm going to go ahead and save this chat right now so we capture it, and the meeting has been recorded. So unless anybody has any other final thoughts, I think we'll go ahead and close.
Thanks, Ed. Thanks, Annie.
Good. Well, thanks everybody for your participation, and see you guys later in the meeting, later today and tomorrow. And thanks, Annie, for hosting and all the logistics.